Hey everybody, this is Caleb, and today we're going to go ahead and break down some stuff in chemistry. Today in this video, we're going to go ahead and look at what is an atom, the history of an atom, what is energy, how to find frequency and wavelength, and finally, we're going to go ahead and look at an atomic mass problem. So let's go ahead and get started. First, what is an atom? I'm not talking about your next door neighbor named Adam. I'm talking about the basic unit of a chemical element. When you think of what things are made of, the things that pop into mind are probably wood, leather, cotton, and so many more things. But what are those made of? Everything is made of atoms. And without atoms, we wouldn't have anything. So speaking of atoms, we're going to go ahead and go right into the history. There are so many moments of an atom's history that we could cover, but we don't have that much time. So I'm going to go ahead and hit some of the major moments of the atom's history. The first one was in 1803 when Dalton conceived the principles of the atomic theory. Next was J.J. Thomson when he discovered the electron in 1897. And finally, Chadwick when he discovered the neutron in 1932. There are so many more times in history that we could talk about for an atom, but these are three of the biggest, because these really helped us to determine what an atom is, what it's made up of, and how it stays stable. So now we're going to go right into what is energy. When we think of energy, we think of your phone, a car, or flipping the light switch in your house. But we're going to take it down to the basics. Energy is just the ability to do work. And so with that, how do we find frequency and wavelength relating that to energy? So before we can do any of that, we need to figure out how to find it. So we're going to take our handy dandy little circle here. That is speed over frequency and wavelength. So if you're going to want to find frequency, just go ahead and cover that up. And to go ahead and find it, you're going to take speed over wavelength. If you want to find wavelength, go ahead and cover that up. And you're going to find it using speed over frequency. And finally, if you want to find speed, just do frequency times wavelength. And so with that, let's go ahead and look over at our equation, which is C, which is speed of light, is equal to wavelength times frequency. And the speed of light is 3 times 10 to the 8th meters per second. So let's go ahead and jump into our first example here. Our first example is violet light has a wavelength of 4.1 times 10 to the negative 12th meters. What is its frequency? So let's go ahead and look at this. We want to find frequency. Go ahead and cover this up. So we need to do speed divided by wavelength. So steps. So take our equation and plug in what we know. We know C, which is speed of light, and we know the wavelength. So it's 3 times 10 to the 8th meters per second is equal to 4.1 times 10 to the negative 12th meters times frequency. So as I said, we need to do speed over wavelength. So when you do that, you have 3 times 10 to the 8th meters per second divided by 4.1 times 10 to the negative 12th is equal to the frequency. And when you do that, plug it into your calculator, it should be frequency is equal to 7.32 times 10 to the 19th hertz. So moving on, let's go ahead and get into atomic mass and how do we find it? Well, here we go. What is the AMU, or atomic mass, of silicon, given the following abundance information on the isotopes of silicon? So, here's our atomic mass table. We are given that silicon-28 and its abundance of 92.21%, silicon-29, which has an abundance of 4.7%, and finally, silicon-30, based off of 3.09 abundance. So we're going to plug it into our formula. So we need to take our numbers given and add them up just like this. So since the first one had an abundance of 92.21%, we need to go ahead and move that over and make it a decimal. And when you're converting a percent into a decimal, you just move the decimal place over 2 to the left. So we get 0.9221 times 28, and the 28 comes from the mass number. And you're going to go ahead and add that with the abundance times the mass number of the second one, And again, we're going to go ahead and move that decimal to the left 2 for the abundance. So that gives us 0.0470 times 29. And then we're going to go ahead and add on the last one, which has the abundance of 0.0309 times 30. So as you do this, we're going to go ahead and calculate each one, add them together, and that is how we find our AMU, or the average mass. And when we do that, the average mass is 28.11 AMUs. So, as we wrap up this video, we have learned all about what is an atom, the history of an atom, what is energy, how to find a frequency and wavelength, and then we wrapped it up with an atomic mass problem. So I hope you are able to use this in your everyday chemistry class, and have a great rest of your time in chemistry, and I hope you learned a lot.